Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Nafis Dwi Kartiko from Information System. In this occasion, I would like to explain about the role of the machine learning in the corporate bankruptcy prediction. I will explain about the advances, ensembles, imbalanced data, and explainable AI in machine learning. The learning outcomes, this video, the first outcome is to understand the paradigm shift from traditional statistical models to machine learning. And then the second learning outcomes, explore high performance ensemble algorithms like random forest and XGBoost. The third learning outcomes is address imbalanced financial datasets using statistic synthetic minority oversampling technique or SMOTE and demystify black box predictions using explainable AI or SHAP framework. The financial cost of the corporate insolvency, we can see that the bankrupt firms have impact to the supply chains, creditors, shareholders, and employees. The early prediction enables proactive risk mitigation and empowers institutions to stabilize assets allocations. The traditional predictive models, we can separate between two analysis. The first analysis using univariate analysis from Beaver, the first statistical justification for financial ratios indicating default, and the second analysis we can using multivariate discriminant analyzing from Altman. This is the famous models, yeah, we can call it Z-score models. The Z-score model from the Altman reflected the liquidity, profitability, leverage, and the activity from corporates to predict the bankruptcy. As we can see in this presentation, the limitation of the traditional statistics. The first limitation is have a strict assumptions like a multi-discriminal analysis, assuming variables follows a normal distribution. And then the second limitation, it's only using linear constraint. They struggle to capture complex multivariable interactions inherent in the modern global finance. And then the third limitation, it's have rigidity, so the models are unable to adapt dynamically as new financial data structures emerge. We can see at the uh, left scheme, the left schemes using traditional linear model, it's not capture the complex of the financial data structures, and then in the right schemes we can see the non-linear classification, the goal how to separate between two classification of the data. So to address this problem, the machine learning can shift this paradigm from the traditional statistic to machine learning. The machine learning algorithms process high-dimensional and then non-linear financial datasets without requiring strict statistical assumptions like the normal distribution. And then the modelers in the machine learning can learn intricate data patterns to dynamically classify the companies based on their true bankruptcy risk profile. We can see in this scheme that the heterogeneous financial data from balance sheets and income statement can process using high dimensional with the machine learning models to create the risk probability of the company from 0 until 1. So this is the algorithm in the machine learning, ensemble learning using random forest. In the random forest, aggregates hundreds of the independent decision tree to reduce variance and prevent overfitting. consistently achieve over 95% accuracy in corporate bankruptcy detection by evaluating subsets of the financial ratio. So, from the majority vote, we can separate between bankrupt company and live company. And then the second model or the second algorithms using gradient boosting. In this occasion, we can study about the SG boost and like GBM. The SG boost in here have a highly accurate and scalable tree boosting. On the other hand, the light GBM utilize leaf-wise growth for superior efficiency and speed with the high dimensional financial data. Other algorithms to predicting the bankrupt company, we can using SVM. SVM is support vector machines and deep learning using ENN. The SVM can create the projects from the financial data into the high dimensional space to find the optimal separating hyperplane between healthy and the distress firm. Distress firm here is reflective bankrupt firms. And the other hand, deep learning, this model employs multi-layer networks to extract hidden sequential patterns to occasionally prompt to overfitting on smaller datasets. And then the next problems, it's about the imbalanced data problem. Corporate bankruptcy is fundamentally a rare event. As for example, in here, only 3 until 6% of the datasets. So the standard machine learning models trained on this queue will heavily bias toward predicting healthy firms and severely damaging real-world risk detection. So to this problem, we can using smoother solution or synthetic minority oversampling techniques. In this model, this method interpolates between existing minority samples to generate synthetic bankrupt profiles. Smoother can eliminate majority class bias without losing critical information. So, in the first figure, we can see failed and live firm before Smoother, and after Smoother, we can see the count or the total samples between live, a live and a filed company is same. From the preface literature, we can look the rigorous model evaluation. We can see the random forest, decision tree, logistic regression, SVM, and KNN. The random forest is the best algorithm to predicting bankruptcy. Post-model, random forest achieves 95% accuracy and 97% recall, and this algorithm successfully identifying true default while minimizing false alarms. And then we have the black box dilemma. Despite exceptional accuracy, complex machine learning models lack of the explicit interpretability. So the financial institution face the strict regulatory requirements like right to explanation to justify credit denials or risk downgrades. So to clear this problem, we can bridging the gaps using explainable AI. The explainable AI methodologies, it can be extract the internal logic of the high performance model, transform opaque prediction into transparent, statistically driven insight acceptable to auditors, regulators, and the stakeholders. Is it the global interpretability, like using SHAP framework, based on safely values from cooperative game theory, they set the critical variable to predicting bankrupt company. They say the local interpretability using single prediction analysis. As Hub-Force plot explain the individual corporate assessment, the navy figures push the probability of bankruptcy higher, and then the sky blue figures push the probability lower. And this figure reflected as Hub summary. It's contain key financial indicators decode like net interest income, total debt, and etc. The net interest income here, why it's so essential to predict bankrupt company, lower dependency on net interest income improves credit score and highlighting the needs for the revenue diversification. As the closing and the strategic implication, integrating machine learning pipelines save the institution from reactive monitoring to proactive oversight. Combining ensemble models with explainable AI ensure bank or the company achieve the maximum predictive accuracy while maintaining strict regulatory transparency. From the risk management, they can using machine learning automate pipelines and have interpretability and compliance to the state or regulatory. And then this is the summary, the modern prediction pipeline to predict the bankruptcy companies. The first is data preparation to resolving imbalance to reveal true risk from the raw financial data, and then we using smooth balancing and make a model using ensemble modeling to leveraging non-linear and high-dimensional algorithm. And then we can using ASAP interpretation and using ASAP summary, for example, to make the explanation to decoding the black box for human-centric financial decision making until we can take the action from the actionable insight. This is the reference to this study. I'd like to say thank you to watch this video.